Hey, hi everyone. Welcome back to my YouTube channel. My name is Sunny Savita and I'm back with another exciting and important video. With this particular video, guys, we're gonna continue our fine-tuning series, which I started in my previous video. There, I just explained the syllabus of the fine-tuning, and I told you that in our upcoming 10 to 15 video, we are just going to discuss the fine-tuning concept, the LLM fine-tuning concept, but unfortunately I couldn't upload a video in my last couple of days. So the last video which I uploaded, it was 2 weeks ago. And I know, guys, many of you messaged to me, you written in a comment, and even I got the personal message, sir, why you stop this fine tuning series and all. So again, I'm saying I didn't stop it. I will upload all the video as it is, whatever I said. Um, because of the work pressure and all, I just took a break, and even I was involved to create some refined content for this fine tuning series. So that's why, guys, I couldn't record a video. But don't worry, now I'll try to upload a video. As much as video I will try to upload inside this playlist, and I will make sure that you will get enough content from my YouTube channel. Okay. So yeah, fine. I think I discussed all the stuff, all the thing, whatever was in your mind. Now, first of all, let me show you the syllabus which I discussed in the previous session, and then I'll come to the agenda of today's video. So here, guys, all the thing I kept inside my OneNotes. So this is the syllabus, and first of all, let me discuss this entire syllabus. So the syllabus itself, I told you that we are going to discuss the complete and the detailed introduction of the fine tuning. Yes, in today's video, we'll discuss the detailed introduction of the fine tuning. Then we'll discuss the differences between the fine tuning, RAG, AI agents, and all everything. Then we'll come to the fine tuning in the deep learning. Is why this fine tuning is possible in the deep learning. Okay, why, how it came into the picture, each and everything we'll try to discuss inside this particular lecture. Then why fine tuning is not possible inside the RNN LSTM, and here you will learn some significant differences between the LSTM, RNN, and the transformer architecture. Then the Hugging Face and the LangChain, because LangChain does not provide any support to the fine tuning; it only support to the RAG-based application and the agentic application and the application which we productionize, right? That so, guys, for the fine tuning, for sure we'll have to learn this Hugging Face, because Hugging Face provide all the open source model and even the support for the fine tuning. There is a library like the transformer, there is a library like the dataset, TRL, accelerate, right? All those library is support to the fine tuning stuff. So for sure we'll have to learn the Hugging Face, which is very much important and the important concept of this entire syllabus. Then the fine tuning in a classical language model like Bert and all. Knowledge distillation is also very important. People can ask you in an interview. LLM quantization, again, it is a very important, just to basically reduce the size of the model and to load it in any sort of a configuration. Then here is the fine tuning of the large language model. The main concept will start from here, right? So the concept basically which you are waiting, right? So the concept will start from this particular stage. And then, guys, API based model, and then framework for the large language model. Okay, then the fine tuning for the vision language, because right? So vision modeling is also going to be a very popular now, and even the Chat GPT has integrated many multi-model stuff right inside their application. So definitely we'll have to learn about this vision, fine tuning of the vision language model, and then reinforcement learning with a human feedback. Very important concept, guys. And we'll see some advanced concept like the DPO and all, and the embedding fine tuning. So this was a syllabus which I discussed in my previous video. Now it's time to discuss about the introduction of the fine tuning, and without wasting a time, we'll start, guys, the introduction of the fine tuning, and I let you know the each and every point. And again, I'm saying, guys, see, my video is going to be quite long from now onwards, because I will not discuss the thing on surface. I will discuss each and everything in depth. So if you are interested to learn everything in depth, then stick with my video. Otherwise, this video is not for you, where I'm going to complete any sort of a topic within 5 to 10 minutes. I can do that. For sure, I can do that, but I'm not going to do it. Okay. So yeah, let's start with the introduction of the fine tuning, and then I'll show you the practical stuff also. So guys, as you can see, I divided this introduction of the fine tuning into the multiple section. So the first section we are going to discuss what is a model training. I want to start from scratch. So first I'll show you what is a model training, then what is a pre-training. So this pre-training, it plays a very important role in the fine tuning, and we need to understand the pre-training with respect to the LLM models. Not only the LLM model, I'll try to explain you this pre-training with respect to the other deep learning model like CNN based model. Then there is a concept of the transfer learning. So we'll discuss what are type of transfer learning we have, how we can modify the layer of the architecture, and how we can achieve this transfer learning, and where this fine tuning exists inside this transfer learning. Then guys, we have some theoretical concept like advantage and disadvantage of the fine tuning, then LLM fine tuning libraries. So whatever libraries we have, I will try to explain you about those library, and we'll discuss which library you can use. Then we have these important research papers. So there are a couple of research paper which is very much important, and you should follow those research paper if you are trying to learn the fine tuning stuff. Then guys, we have a next topic which is tips of our fine tuning. So yes, you can follow a couple of tips which will enhance your model training and the fine tuning result. So that we'll discuss at the end of the video, or maybe I can divide this particular video into two sections. Where in the first section means in this particular video, I'll try to discuss about this model training, pre-training, and the transfer learning. Again, guys, again I'm saying for the transfer learning, I have uh, I have recorded one specific session. So most probably after this particular session, one more session will come with respect to the RAG versus fine tuning and agents, and then I will upload this transfer learning session. So I will explain you most of the theoretical stuff in this particular section, but yeah, in the next session, I will try to discuss the practical also. Now let's begin with the model training. So what is a model training in the end? Let me switch off my camera so that you can access the entire board and you can understand in a better way. Okay. So here you can see guys, I written this entire notes written by me, and I will provide you this particular notes and this so that you can follow it, and you can prepare the fine tuning stuff and all. And whenever anyone is asking you any sort of a question related to the fine tuning and also easily you can answer. Again, I'm saying guys, this notes is created by me. Mindfully, I created all the notes. Okay, and that's why I took this much of time to upload a next video. So first of all, guys, we'll try to understand where this fine tuning lies inside the model training. So whenever we discuss about the AI, guys, so this AI on a very high level, we can divide into the multiple section. So here I can write AI. So under this AI, you will see machine learning. Under the machine learning, there is one specific kind of AI which we develop using the neural network, that is called deep learning. Now again, we can divide this deep learning into the multiple neural network. So the vanilla neural network is called the artificial neural network. Then there is a CNN, which is called convolution neural network. And this convolution neural network we use for handling the image kind of data. Then we have a recurrent neural network, which we use for handling the sequence kind of data. Then we have gains and autoencoder. Earlier, it was using for generating a data, and this gains is nothing. This gains basically it was built on top of the CNN itself. Then we have one more kind of learning, that is called reinforcement learning. So inside the reinforcement learning, we always perform the reward based learning, and we use the policies over there, and here also we can use the deep neural network. Okay, so this is called deep RL, deep reinforcement learning. Now guys, whenever we talk about the generative AI, the agentic AI, where it lies, so here inside the CNN, guys, you can see. So CNN, using the CNN architecture, we can achieve basically some state of art model, right? So there the you will find out the evolution of the CV computer vision. And inside the RNN basically, right down the line in the RNN itself, so they have created one architecture. The architecture name was the transformer. Again, guys, this RNN model was they were using for handling the NLP related problems. So down the line in the RNN itself, right? So there is a variant of the RNN like the LSTM and the GRU, as you know, right? Which we were using for handling the NLP related task and all the sequence to sequence related tasks. Okay, so there was itself we were having one more architecture. The architecture name was the transformer. So this transformer architecture basically it was very efficient to solve the like sequence to sequence related problem, and because of this particular architecture, the evolution of the generative AI started. So they have created some early stage LLM like the Bert and GPT, and nowadays we can find out many state of art LLM, and because of this transformer only. So inside this transformer architecture only, they did some fine tuning and they have changed some layer according to their requirement and all, and they created a very powerful model. So here from here itself, guys, you will see the era of the LLMs. Now, guys, this transformer architecture is not only for sequence to sequence data. After processing this image kind of data, video kind of data, again we can handle it using the transformer only. Okay, so nowadays we are using this transformer in the field of vision as well. Now coming to this generative AI, so now we have a LLM, guys, and using the capability of the LLM, we have created one more kind of AI. The AI is called agentic AI. So inside this agentic AI, what we are doing, we are using the capability of the LLM, we are using the brain of the LLM, and uh, we are doing a certain actions and all, and we are we are able to achieve some like a good result. Okay, so we are able to do too much automation inside this agentic AI. So this is a complete map or complete roadmap, right? Whenever we start learning this AI and all. Now, why I explaining this all this thing so that I can discuss about the model building and I can tell you where this fine tuning lies, okay, and where this fine tuning has started, okay, in the deep learning, in the machine learning, or specifically in the AI world. So guys, whenever we talk about any model building, so first we collect the data, then we analyze the data, then we pre-process the data, right? And then only we perform the model building. If I'm saying model building, so the simple meaning is model training. We are going to train a model on some specific data. Okay, we have our data on top of the data basically, right? So we are going to be train a model. And again, see if I'm saying a model, so again, the model is nothing. What is a model? So model is a mathematical equation. Okay. This all the thing I already explained you in my previous videos, in my history of the AI video. You can go and check over there and you can get a knowledge in very, very detailed manner. Okay. The complete history of the machine learning AI and all, right? Now, guys, coming to some generic thing. Okay. So just I'm just giving you the refreshment of the machine learning, deep learning algorithm, and then specifically I'll talk about the then specifically I'll be talking about what I'll be talking about the fine tuning. So first of all, let me clear the ground. And again, guys, this note was created by me, and you can utilize it in a better way just to refresh your concept. So let's say we have a machine learning. So it's the machine learning, guys. We have a supervised modeling. So these all are the algorithm belong to the supervised modeling. Okay, and then we have unsupervised modeling. So this all the algorithm, the clustering algorithm actually belong to the unsupervised modeling. So K means clustering is there, hierarchical clustering is there, okay, DB scan clustering is there. So unsupervised means we don't have like a target column, okay, and supervised means we have a target column. Now, we're talking about a deep learning, guys. So the deep learning, you can see we have an artificial neural network, we have a convolution neural network. Okay, and on top of the convolution neural network only, they have created a couple of very efficient network. Okay, which was able to solve this object detection, object segmentation, object tracking, object optical character recognition kind of task. So here I written the name of those model which was inspired completely from the convolution neural network. Okay, so this was the early stage architecture of the convolution neural network, which was able to solve this image classification kind of thing, that like image classification kind of thing. They are able to classify the image into the multiple classes. They are able to perform the supervised learning on top of that, and the label and the model name was the LeanNet, AlexNet, VGG, ResNet, and DensNet, right? And these was all the tasks basically which we can perform inside the CNN, means using the CNN and inside the computer vision. Okay, so I hope so, guys. This entire thing is clear and you got some kind of a refreshment. Now coming to the NLP, guys. So whenever we talk about the NLP, so the NLP story begins from the RNN. So this RNN network was developed to handle the sequence kind of data. So if I'm saying the sequence kind of data, so I'm clearly talking about the text data. Okay. So we have a text data, and like what we are doing, guys, we are doing a sequence to sequence learning using this text data. I will create one more playlist where I will explain the RNN LSTM also. So what was this model and how they have created it and why it got failed in front of the transformer. Each and every discrimination, each and every differences we'll try to see. Okay, so we have a RNN, we have a different variants of the RNN. Okay, like LSTM and GRU, and using this RNN models, RNN based model, we are going to be solve these tasks like text classification, text summarization, question answering, text generation, and the text translation. Okay, so these are some fundamental tasks where these are the some fundamental tasks in the NLP. Okay, in the NLP. On a fundamental level, each and every task is a text. At the end, it is generating a text only. Okay, so keep that thing also in your mind, and how it is doing that using this sequence to sequence learning, which we are able to achieve using what? Using this RNN and LSTM model. So guys, I hope this all the thing is clear. But why I'm telling you all this thing? Why I am taking like a 5 to 10 minute extra just to explain you all this step? In some time, all the thing is going to be clear. But so first of all, you will have to focus on these points. So here in this point, what I mentioned. So whenever I'm talking about this RNN LSTM kind of model, so here I'm doing a model training from very scratch. Okay. And one more thing, guys, here I mentioned I'm doing a task specific training over here. Task specific training means what? Task specific training means, let's say if I have to do the text classification, then I'll do that. Text summarization, then I will train a model on top of it. Then question answering, if I want to question answering, then I will train my model again from scratch on top of it, right? So I'm doing a task specific training. I hope you got to know the meaning of the task specific training, right? So guys, so far what we understood, we are trying to train a model. Okay, and we are trying to train a model on top of some data, and this model training actually it is from the scratch. Okay, SCRATCH. Now where this fine tuning lies, okay, and uh, where this fine tuning lies and how we were able to achieve this fine tuning. So guys, the era of the fine tuning has started in 2011 itself. Okay, and guys, you won't believe the era. This fine tuning actually the first time it was introduced inside this CNN. Okay, inside this CNN, using the CNN model only. Means the fine tuning was not introduced using this RNN and LSTM model. And guys, you won't believe using this RNN and LSTM model, even we cannot achieve the fine tuning perfectly. Okay, so the fine tuning was introduced inside in 2011 itself. The one competition was launched. The competition name was the ISLVRC, right? So I'll let you know the full form of that. Okay, and we'll talk about it because I have to discuss some pre-training concept also. So I kept it in my next slide. So guys, in 2011, that competition have been launched, and during that competition, some of the model was introduced, and those model basically have been trained on a very huge amount of data. So this LeanNet model and this LHNet model, whatever model you can see over here, this model have been trained on that time itself. Okay, and that in that era itself. Okay, during the 2011 to 2015. And ResNet is one of the very successful model in that. Even the efficient net, dense net, Google net. So this all the model basically was introduced at that time itself. So we are talking about the fine tuning, guys. So this fine tuning, in the fine tuning, what happened, So we perform the model training. Means all the steps will be as it is. Means there will be a data collection. Okay, data collection. Then we do the uh, whatever analysis and pre-processing we have to do, right? Pre-processing of the data, we'll do that. Then after that, we'll do the model training. Now this model training now will do on a huge amount of data. Okay. So we will do on a very huge amount of data so that my model can learn the pattern, each and every pattern from the data. Okay. Now guys, this model is called the pre-trained model. This model is called pre-trained model. Okay. Now further this pre-trained model, what I can do, further this pre-trained model, I can use as it is. Okay. As it is means without any changes, I can use this particular model as it is. Or else what I can do, or else I can fine tune this model. Fine tune the model. So what you understood from this entire story, you understood from this entire story, we were having the classical model, we were having the machine learning, deep learning, and this basically RNN and the CNN and all. But guys, the fine tuning era has started from 2011 itself, and where not in the NLP, it was started in the CNN, in the computer vision. Okay, and in the fine tuning, we should have one pre-trained model. And this pre-trained model basically it should train on a very huge amount of data so that we can capture each and every type of pattern from the data. And further, we can fine tune that particular model on our specific task, right? So this is the entire moral of the story. Okay, that's why I just gone through with this all the steps so that all these points basically so that you can understand the crux from the very basic. Okay, now, I have to tell you guys one more thing. So, how this fine tuning has started in the field of this one NLP, okay, which was the model which we have used like the first time to achieve a fine tuning inside the NLP. That's a still mystery, right? So we have to understand that. And guys, don't worry, I kept all the thing over here so that in a clear cut way you will be able to understand how this fine tuning how this fine tuning era has started inside the NLP. Now let's try to understand this particular concept. Okay. So guys, whenever we talk about the fine tuning inside the NLP, right? So we always discuss about this research paper. The research paper name is Universal Language Modeling using Encoder and Decoder Architecture. So here, guys, I would like to introduce two research paper, right, which is mandatory for learning. And if we are very interested, right, to understand about the in depth of the NLP, right? So this two research paper you should go through. The first research paper is an encoder and decoder, which was published in 2014. Okay, there even though they have used the this LSTM and the RNN model, but again, guys, there are lots of concepts have been discussed inside this particular research paper. The next research paper is was published in 2018, and the research paper name is what? Universal Language Model Fine Tuning for the Text Classification. So, guys, this research paper actually it's a real starting of the it is a real starting of the fine tuning in the NLP domain. Okay, and there is one more research paper. The research paper name is Neural Machine Translation by Jointly Learning to Align and Translation. If you're gonna read this all the three research paper, guys, believe me, your understanding will be much more complete in the field of in the field of this NLP, right? And even you can understand the transformer in a very good way, right? In a better way. So guys, here I mentioned just try to read all this thing what I mentioned. So one of the key milestone was the idea of the universal language modeling using the encoder decoder architecture. So what they have done, they have pre-trained one model, okay, and the pre-training basically it happened using this machine translation task. Okay, so guys, as I told you, whenever we talk about the fine tuning, so for the fine tuning, guys, we always should have a pre-trained model. If we don't have this pre-trained model on a huge amount of data, right? On a huge amount of data, in that case, we cannot perform the fine tuning. So inside this research paper, what they have trained one very huge model. Okay, it was not very huge compared to the like today's model, but yeah, at that time basically it was a huge. So it was a large scale text data which was used for training a model using this machine translation task so that my model can learn. Okay, using this particular task, my model can understand the grammar and the nitty-gritty detail of the data. Then what they have done? Then further they have fine-tuned that particular model for what? For the text classification task. So downstream, down the line, they have fine-tuned that particular model for the text classification task, and the result was super. Okay, so compared to the other architecture, the vanilla architecture, the vanilla LSTM and the RNN, which we are training from scratch, right? So the result of this particular approach was quite good, and this is the first milestone, the key milestone in the field of NLP regarding the fine tuning. Okay, I hope you understood it now. So here you can see inside this particular model, right? So inside this particular research paper, what was the limitation? The limitation was very like a straightforward. So for the pre-training task, they were using a machine translation, and using this machine translation, they were not able to teach the model in a very good way, right? So the model was not learning anything, right? Model was learning. See, anything is not a correct word. I would say model was not learning everything. Model was just learning something. Okay. So here, guys, the issue was the machine translation task was not good for the pre-training. That was the first thing. The second thing, basically, they were using the LSTM. Okay, and LSTM and the RNN model, these are not good for the. Okay, guys, just give me a moment. Yeah. So guys, this RNN and LSTM model actually is not a very good model for the long-term dependency. Means we cannot handle very long sequence using this RNN and LSTM model. And it was also not a computationally inefficient. Okay, so it was not very computationally efficient. Means it was a very inefficient model in terms of the long sequence data, and because of that, this model, this research paper, basically they have introduced the fine tuning, but it couldn't scale the entire idea. Okay, now guys, the game changer, right? So here I have mentioned the game changer transformer enter. And now once it entered now guys in the story, in our story, right? So the entire thing got changed because this transformer architecture is, it was not using the LSTM and the RNN at all. Okay, it was not using it. So guys, it has like what they have done, they have introduced something else. They have introduced a concept of the self attention. Actually the self attention concept uh, was inspired from this particular research paper, this machine translation by jointly learning to align the translation. Okay, if you'll go and check this particular research paper, they have defined the concept of what, they have defined the concept of the attention. Okay, now that this attention basically it got converted into the self attention further. So here you can see, so we are having the self attention inside the transformer architecture. And guys, this is the specification, a quick specific, like a not a very detailed one, but yeah, it is a like a specification of the transformer model. There is an input layer, encoder, decoder, and the output layer. In some other session, I'll try to discuss about this transformer and all. Okay. So, guys, after release of this success, or after release of this transformer, guys, so there was some model was introduced, like a Bert model, GPT model, T5 model, XLM model. Now, this all the model actually it was based on the transformer only, right? And this model basically it was a quite good. Now, what was the advantage inside this particular model? So the advantage basically, let me write over here. As I told you, so whenever we talk about the fine tuning, right? Whenever we talk about the fine tuning, so what we required, please mention in the comment if you know. So whenever we talk about the fine tuning, we required some pre-trained model. Okay, and this pre-trained model it should train on a huge amount of data, huge amount of data. Okay, now guys, earlier they have pre-trained this particular model, pre-trained the model. Okay, using the machine translation task, using the language translation task. But as I told you, this language translation task was not very efficient. Okay, so two more tasks have been basically published, right? So in Word research paper, they have published about the mass language modeling, And in GPT, okay, in the GPT research paper, they have published about the causal language modeling. So in mass language modeling, what we were doing, so we were masking what we were doing, we were masking the random word, okay, inside a particular sentence, and we were trying to predict that. And inside the GPT model, what they were doing? They were trying to predict the next word, okay. They were trying to predict the next word inside the given sentence. So this two task was introduced, guys, and you won't believe. MLM was also fine, but this causal language modeling (CNN), okay, it is also called a regressive modeling. So it is also called what? It is also called a regressive modeling. Using this particular task, when they have trained a pre-trained model on a huge amount of data, now, guys, the result was amazing. Means what I'm trying to say. So they want the pre-trained model. Okay, now, how they can get the pre-trained model? So they can get a pre-trained model using the machine translation task, but this was not a good. So they have introduced two more techniques. First was the MLM, mass language modeling, and second was the causal language modeling. This is also called regressive modeling. Okay, regressive modeling. So guys, inside the mass language modeling, you know what we are doing? We are trying to predict the masked word. Okay, masked word inside the given sentence. Okay, so this was fine. This was okay. And the entire word concept, it was based on the mass language modeling. But guys, when they have used this particular technique now, causal language modeling, there they have to predict the next one. Okay, next one. So using this particular technique, the model they have generated, right? The pre-trained model they have generated, the pre-trained model was very amazing. Now, uh, uh, whatever current model you can see, right? So whatever GPT based model, whatever like a Mistral model, okay, Llama model. So this all the model actually it is based on this technique only, okay, causal language modeling, where they're trying to predict the next one. And this was a decoder, okay. And how they were doing that? They were doing that using the decoder of the transformer, right? They were picking the decoder of the transformer and they are trying to perform this particular task, the next word prediction, causal language modeling, and they were pre-training that particular, they generated a pre-trained model, okay, and the model was super. Now, further, this particular model we can fine tune, okay, further, this particular model we can fine tune. I hope you understand. Now, you were asked to me, Sunny, why we are doing this pre-training? What is the aim of this pre-training? So the aim of the pre-training is very, very simple, guys. So the aim of the pre-training is we want to teach to the model. Okay, we want to teach to the model. We want to teach to the model the nitty-gritty detail. Okay, the nitty-gritty detail. Nitty-gritty detail means small to small detail. So we are training our model on a next one prediction. Okay, on top of this next word prediction. In that case, my model trying to learn something from the data. Okay, my model trying to understand the language. Okay, my model trying to understand each and every pattern, and that was the advantage of this. That was a like very huge advantage of the causal language modeling. We are able to teach a pattern, each and every pattern from the data, and because of that, we are able to get this GPT kind of model, and we are able to build this chat GPT kind of application, guys. I hope everything is getting connected now. So what you understood from this entire thing, if we want to fine tune the model, okay, so we no need to go through with this classical approach. We are just going to do the model training around. No, it will not be a simple model training. It will be a pre-training. Okay, pre-training means pre-training is also kind of a training, but again, pre-training basically on a huge amount of data. And for the pre-training, guys, we have some technique, right? For the CV, we have a technique, right? We are going to use the CNN architecture, and in NLP, guys, we have this transformer-based architecture. Inside the transformer-based architecture, again, we're gonna use the uh, either mass language modeling or this causal language modeling. Okay, causal language modeling is next one prediction, and this was the very efficient technique. If you're talking about the efficient one, the best one, so this was the best technique. So yeah, I hope I've given you the enough detail. Now let's try to understand the further things. So we were able to get the word, we are able to get the GPT, then the chat GPT came. Okay, So ChatGPT have introduced one more level of training, that was a reinforcement learning through the human feedback. Now let's try to revisit the steps. So if we want to get a pre-trained model, okay. So first we collect the data, then we clean the data, analysis the data, pre-process the data. Then we have a unsupervised pre-training using the GPT, means using this causal language model, the next word prediction. Okay. So yeah, here you can see the GPT based model, decoder based model. Okay. Then we have an evaluation of the model using the perplexity, loss, token accuracy, and all. Okay. Now, here, guys, I have a mention about the pre-training. You can read about it. So, what it is a phase where model is learning everything from the data. Okay, it is an auto-regressive language modeling, predict the next word, next token. I'm talking with respect to the NLP. Okay, I'm talking about the evolution of the GPT model. I'm talking about the evolution of this Chat GPT application. Again, I'm saying Chat GPT is an application. Okay, GPT is a model. So Chat GPT is an application. Then guys, here we are going to build a foundation model. Now again, I'm saying this pre-trained model itself. Okay, pre-trained model itself is called a foundation model. So if someone is going to ask you what is a foundation model, so this pre-trained model only, it is called the foundation model. So once we'll get the pre-trained model, guys, now further we can fine-tune that model. Okay, we have a supervised fine-tuning technique inside the LLMs, right? So we can perform the fine-tuning using the PEF technique. We can perform the fine-tuning using this LoRa, and all. Each and everything will try to learn going forward. And then there is one more type of fine-tuning was introduced from the ChatGPT and from the OpenAI end. That fine-tuning was the reinforcement learning through the human feedback. Means first we'll generate a result, okay, and then whatever result is being generated, then we'll try to find out which is the best result, means which is the best result, and then again we'll try to align that particular result with the human question, so that my response will be a more controlled and will be a more accurate. Now this RLHF is being replaced by this DPO technique. This is called, that is called direct preference optimization, DPO. Okay, and we'll try to understand this DPO also in the upcoming session. So guys, now now you are welcome to the LLM era, where we have a different LLM from the Llama, Mr. Jimny, DeepSeek, Cloud, and GPT and all. And here you can see, guys, this is a complete the sequence, okay, of the training. So first will get a pre-trained model, then we can fine tune that particular model. Then basically we can further fine tune it, we can further perform the instruction fine tuning and all. Okay, then we can perform the RLHF and all, and this continuous learning is going on, right? So this is the complete, this is the like conclusion, guys. Okay, the entire conclusion which I was trying to explain. Now what I will do, I will come to this pre-training, guys. We'll try to discuss couple of more things with respect to this pre-training, and I will try to show you the practical of this pre-training. Okay, and then we'll try to understand this transfer learning and the fine tuning as well. Means what it is. I'm not going in a very detail about this transfer learning and fine tuning. I'll just give you the surface level idea. Okay, then in one of the session we'll try to discuss it in a very detailed way. Okay, so your complete introduction, right? Complete introduction of the fine tuning is not going to be complete in this particular class. It will complete in the next class, because there is a couple of more points: advantage, disadvantage, library, and all. So I'll record one more video regarding this one. Now let's try to understand about the pre-training, guys, in a little detailed way, and then we'll see the practical of it. So guys, what is a pre-training? What is a pre-trained model? Now let's try to discuss in a little detailed way. So here, pre-train means let first teach the model on some basic knowledge before asking to a specific task. Okay, before asking it to do a specific task. Okay, so let's take an example of the NLP. Okay, in NLP we have the GPT and the Bert and the Llama kind of model. So this Bert and GPT, it is called the early stage LLM model. Okay, and the Llama and then Mistral, then other model, the Gemini and all. Okay, this is called a state of art model, which was recently launched 1 or 2 years back. Then, guys, here you can see feed it tons and tons of general data like books, website, Wikipedia, and articles. Okay, feed this data to the model. Means what's the meaning over here? If we are feeding a data, means we are training a model, right? We are training a model, and this training is called pre-training, right? Pre-training model. And the model which we are going to create, this model actually it's called a foundation model. Okay, foundation model. Now further this foundation model we can use in a various way. Okay, means this model I can use as it is, or I can do fine tuning of this particular model. Okay, fine tuning of this model. Now again in the fine tuning, so either I can just change the last layer, the last output layer. Okay, or the next one is I can change couple of I can freeze all the layer and only can change couple of last layer, couple of last layer. Okay, couple of last layer. So guys, this way, right? So this one, this is called the transfer learning. Transfer learning. So here what we are doing, we are transferring a learning, right? Whatever we have learned throughout this foundation model. So either we are going to use this model as it is, that's fine. Okay, we are using a pre-trained model, but let's say if we want to fine tune it, so we can fine tune the last layer, or else we can fine tune the couple of last layer of the model. Okay, in that case what we are doing, we are going to perform a transfer learning, means we are transferring a knowledge of the model, okay, for some other task. Okay, and this comes under this fine tuning. Means if I'm saying transfer learning, yes, transfer learning is what? Transfer learning is nothing, it is just a way to perform a fine tuning. Okay, and how many ways we have? We have a two ways. Either we can only change the last layer of the model, or else we can change couple of last layer and we can freeze uh, most of the initial layer of the model. Okay, this is the whole sort of idea. It will get more clear. If it is getting confusing for as of now, don't worry. Now here you can see the definition. So first teach to the model on some specific knowledge. Then what you have to do. So after that you can further fine tune. Now I given so many examples over here. You can look into it. Now here guys, I someone is going to ask you in an interview that why to use this pre-trained model. So you can easily say deep learning model required a massive amount of data. Okay, and because of that, we cannot train it again and again from scratch. Okay, because if you are going to do like this, in that case there will be so many this computational resource will be associated, and even this is not possible. Okay, it will take a very huge time, effort and all. So this all the thing I have mentioned, that this deep learning model is required a massive amount of data. It's a data hungry model, and then if you are going to train it from scratch, so it's required a huge time, resources and effort. Okay, so using this pre-trained model, what you can do, you can take a shortcut, means someone can train that model. Someone means the big giants, the big company, or even you can also train a model and then you can provide to that community. The community can use this particular model and the development could be a faster in the field of this AI. Okay, this is the whole sort of idea behind this pre-training model. Now let's deep dive into the pre-training model. So I was saying how this pre-training was introduced inside the CNN. Okay, inside the convolution neural network. So inside the convolution neural network, guys, see, pre-training is when convolution neural network is trained on large on a general data set like an ImageNet data set. So there was one data set which was introduced, okay, in the field of this convolution neural network, in the field of this computer vision. The data set name was the ImageNet. Okay, so this data set basically was created by the Fifi Lee. Okay, and she was creating this particular data set from 2006 itself. They were maintaining one database, and inside the database there was so many images. How many images was there? I'll let you know. Okay, I kept all the specification and all. So this particular data set, this ImageNet data set was used for one of the competition, And inside this competition, many intellectual has participated. There was one guy, Jeffrey Hinton, he participated with their own model. The model name was the this one, LXNet. Okay, LXNet was a model name, and he has used that particular model. Okay, on top of this data set, and the accuracy was amazing. Means the error rate was getting very down, and the accuracy was coming fine, right? So guys, here this is some pre-trained model like VGG, ResNet, Inception, MobileNet, EfficientNet, which was further introduced, okay, during this ImageNet competition only, and it was able to achieve a very good accuracy. Whenever we are talking about the CNN model, guys, those inside the CNN model, what it does, the CNN model actually is trying to see, let me give you the example. With this particular example, you will be able to understand a very clear cut. Let's say this is the image. Now, what is this image? This image is nothing. It is a collection of pixels. Okay. So this image is nothing. It is a collection of pixels. So from this particular image, we have to extract the feature, right? We have to extract the feature. Now, if we want to extract a feature from this particular image, we are going to use a technique of the convolution. So in the convolution, actually, what we do, we use some this random matrices. Okay, we multiply this random matrices with the images. Okay, and we try to extract the feature from this particular images. Now, this particular technique is called the convolution, and the convolution neural network we use the same thing. We take some random features. Okay, we multiply it with a real image, and then we try to extract some. We try to like after the multiplication and all whatever we get now, so this is called a feature, right? Now guys, this image is, let's say this image is a human image. Now just think about the human. So in human, guys, there will be a face, right? Over the face, there will be the nose, ear, okay, forehead, cheeks, lips, whatever would be there. Now the primitive feature of the of any human would be a same. Let's say there is a Sunny, or let's say there is some other person. So some other person is also having a nose, eyes, ear, eyebrows, forehead. Sunny is also having a same thing, right? But guys, if we are going to be a more specific, so Sunny's eye is something else compared to the another person. It's a Sunny nose is something else compared to the another person. It's a Sunny's cheeks is something else compared to the another person. Okay, so this that is called the specific feature. Okay, or the complicated or the sophisticated feature. So whenever we're talking about the CNN layers, the CNN architecture, so it is trying to capture the features, okay, feature from the images. So feature I divided into the multiple section: primitive feature, intermediate feature, specific feature, and all. So guys, this primitive feature or even this intermediate feature would be a same, right? Means this edge, lines, corners, okay. This might be a same, right? Or 99% this would be a same. Pattern, curves, blob combination and all. But guys, if we are going into the deeper layer, in that case, some meaningful feature which with that basically we can identify whether this person is a Sunny or someone else, right? So the type of the eye, the face, okay, whatever basically, right? So what we are going to do using the CNN architecture, we are trying to fetch the feature. And guys, let's say if we want to use the CNN model for some other, let's say I train this particular model on a, let's say I train this particular model on a human, okay, on top of this human data. See, I have what I have, guys, tell me. I have the CNN model. Now, this particular model I have trained on a human data, right? There are so many picture where like there is a human, male, female, and all. Now, if I'm giving an image to this particular CNN model, and I'm saying, can you identify whether in the image there is a human or there is some other object? Definitely it can identify that. Okay, it can identify that. But guys, let's say if I will ask inside the image, okay, there is a Sunny or there is some other person, let's say Rahul. So in that case, it will not be able to identify whether it will not be able to answer whether this human is a Sunny or this human is a Rahul, because primitive feature of the primitive feature, okay, primitive feature of the Sunny and Rahul, it will be same. But guys, the sophisticated feature, the deep features, okay, sophisticated feature means the specific feature of this Sunny and Rahul is going to be different. Why? Because Sunny looks like something else and Rahul looks like something else, but both are human. But both are human. So the primitive feature of the Sunny and Rahul will be same, and the sophisticated feature of the Sunny and Rahul will be different. Okay. So what I want to say over here, let's say I have trained one CNN model. I trained one CNN model on a very huge amount of data. Okay. Now this data is a human data. Okay. This human data. So this model, the CNN model, I can use as it is, right? For identify whether the person is human or some other object. So this is called we are using a pre-trained model. Okay, this is called we are using a pre-trained model. But guys, let's say if we have to identify, right? So let's say we have a CNN model. Now using this CNN model, I'm passing an image to the CNN model, and now I have to identify whether there is a Sunny, okay, whether there is a Sunny or there is a Rahul inside the image. In that case, guys, this model is going to be failed. This pre-trained model, right? This pre-trained model, this foundation model will not work. So what we'll have to do? Any answer for this one? Yes, you are thinking right. We are going to fine tune the model. Okay. And in the fine tune, guys, tell me now one more thing will be clear. So we are going to be fine tune the primitive layers or we are going to fine tune this deep layer. Obviously, guys, we are going to fine tune this deep layer because as I told you, this primitive, sorry for the wrong spelling, but just try to understand. So for the primitive layer, guys, right? For the primitive layer, the feature would be same, right? So in that case, we don't need to fine tune this particular model. So what we'll do, we'll try to keep it as it is. We'll try to freeze this layer as it is, and we'll try to retrain couple of last layer, the deep layer, okay, the last layer of the model. That's why I was saying. So if we have any sort of a model, okay, let's say we have any sort of a model. So initially we will try to freeze always the initial layer. Okay, we don't touch this particular layer. We always try to fine tune the last layer because this last layer only it is responsible for extracting the tell me guys what? For extracting the deep features, okay, from the image, the sophisticated or the specific feature. I hope this thing is getting clear. This is what basically I wanted to explain you. So guys, this is the complete detail of the ImageNet data set you can read from here. And ILSVRC, this competition name I was talking about, right? So ImageNet large scale visual recognition data or challenge, right? So inside the ImageNet data set, this much was the images, this much was the validation images, there was some classes and all. Okay. So in 2012, ML plus manual feature extraction technique was used, but the accuracy was not good. Then 2012 onwards, TL model was used, the LXNet model, the accuracy was good, and then error rate was dropping. Here they have used the GPU model, GPU basically platform and the railway models. And so this was a complete chart, guys, how the accuracy was decreasing year by year, okay, and how the pre-trained model was getting succeed, right? Sorry, this fine tuning basically was getting succeed. Okay, they were pre-training on top of the ImageNet data set. They have pre-trained the model on top of the ImageNet data set, and then they were fine tuning for any specific task at that time, right? Now, so guys, here is the convolution neural network. You can see over here, you can go through with it and you can understand this particular architecture, right? There is a multiple convolution layer and at the end you will find out the average pooling and this is the fully collected layer. Okay. Now guys, the second thing is pre-training in the large language model. This is the pretty interesting. So let's try to understand it and then guys, I'll try to conclude the session after showing you a practice. So here, if we're talking about the pre-training in the large language model, so guys, see, what happened? First, we collect the data, the massive amount of data. We tokenize the data. We pass it to the transformer. We put in the next token. Okay, calculate the loss. We do the back propagation and then repeat. So this is the training process, the entire training process of what? This is the entire training process of the transformer-based model. Okay. Now, guys, here you can see we're talking about the transformer and this prediction next token. So what I'm trying to explain over here, I'm talking about the causal language modeling. In the causal language modeling, we're trying to predict the next word. Okay, and because of that, we were trying to teach the model. Okay, the specific language. See here, I mentioned training, objective training. So predicting a next token either using the causal or mask language modeling. So here I mentioned about the pre-training type. So in the GPT model, we use the mask, this causal modeling. In the BERT, we use the mask language modeling. In T5, they were using the span masking. It is one of the variant of the masking. In Palm, Llama, Mr. and all the state-of-art modeling, they are using the causal pre-training model. Okay, and here you can see the number of tokens and all, how many number of tokens they are using, means at which scale, okay, and with which technique. Now, I hope everything is clear. So, from where they are collecting a data, they are collecting a data from the common crawler, from the Wikipedia news article, social media posts, books, GitHubs, and all. From every places they are going to be taking the data. Now, guys, why it is called a unsupervised pre-training? I think you heard about one more term apart from the foundation model and the pre-training model only. Because there is no token, there is no labels. Okay, that you will not be able to find out the Y label over there. Okay, so because of that, it is called the unsupervised pre-training. But guys, this is not a correct one. I try to explore this particular thing. So in many of the blogs, in a couple of research papers, they have said you can use one better word for this particular training, this unsupervised pre-training, which is called self-supervised learning. Why? Because in self-supervised learning, what we do, tell me. Sorry, inside this unsupervised pre-training, what we do, we try to predict the next word now. Okay, and how we get this next word from the data itself, right? So from the data itself, we get a next word. Just look at the example. Here I kept the example, or let me write example. Let's say here I am going to predict Sunny. Sunny is AI master. Okay, Sunny is a AI master. Now, guys, just see. If you want to predict this AI, or if you want to predict this AI, so we'll consider this last two word. Okay, we'll take this last two word and we'll keep this particular word as a target variable. Okay, and we'll try to predict that. Okay, using the model. Now let's say if you want to predict this master, so what we'll do, we'll try to keep this three word, okay, as a X label, and we'll try to keep this master as a Y label. Okay, Y label. So automatically we are going to create a Y label from the given data. So instead of saying this is the unsupervised pre-training, so the better word will be a self-supervised training. Okay, you can say automatically the label is going to be created from the data, and then it is trying to predict that particular label, the next level. So here I written some analogy and all with respect to this pre-training. It's a self-taught student. Okay, first it is teaching to itself, and then basically it's trying to predict. Okay, and if it is required fine tuning of some specific task, then we can do that. Now here I written why this works. Okay, like a magic, because of this pre-training, actually it is able to understand the grammar inside the data. It's able to understand the word order, semantic relationship, and all. Okay, it's trying to understand the crux of the language, and because of that, it's going to work like a magic. Okay, and this one single model. Let's say we're talking about one foundation model. So it is able to do every sort of a task. So it can do the classification. It can what it can do, guys, it can do the classification. Okay, it can do the basically summarization. Okay, this is also possible. The other tasks like a translation and all, so every kind of task it is able to perform because of what, because of this pre-training where we are teaching the model to each and every kind of grammar, word order and all. So this is the example of the board, guys. I kept it over here so that you can understand how the thing was working in the bot, right? And in the bot, basically they were using the mass language modeling, and the GPD they were using the regressive modeling. Okay, this is the transformer architecture, guys, and I hope so. Now you understood this transformer architecture. Basically, we can pre-train and further we can use it as a for the fine tuning. Now, there is a next thing, guys, the transfer learning and the fine tuning. So this particular thing we'll understand in some other lecture. And what I can do over here, I can show you some practical with respect to fine tuning so that your understanding will be much more clear. So I created one notebook. Here you can see inside this notebook, guys, I kept a couple of examples with respect to the CV model, the CNN based model, and the BERT as well. So first, what I'm doing, guys, after connecting with my collab. Okay, so where is the below is the code for the ResNet CV model. Okay, so here what I'm doing, I'm just going to be load the model, load the statement. Okay, all the import statement. Then here I'm going to load the model. Here is my ResNet model. Okay, and I will provide the image path. Let's see whether it will be able to predict or not. So this image, basically, I will have to keep it in my in my collab itself, for my local itself. Okay, so what I'm doing, I'm just going to be upload the image. So I'm just taking one dog image and one, let's say, tomato image. Okay, two image I'm going to upload over here. And then I'll show you the pre-training using using what? Using the Bert also. Okay, so here you can see we are not going to be train the model. So we are just going to be load the model, okay, the pre-trained model, and I'm loading it from the Keras only. And what is my model name? So a model name it over here, it's a ResNet model. Okay. Now here I imported the statement, all the imported statement, that there is a ResNet model. Now I'm going to there is my image path, guys. So this image path I will be passing. First, let me define the configuration of the image. Okay, so here is the image, and then there's a target size. So I'm going to load my image. I got my image, guys. I expanded this particular image. Okay, so into the array, and I'm passing it to the model. So here I will be getting a prediction. So see, this is just my model which I loaded from the Keras library, and here what I'm doing, I'm just doing a prediction, and see this is my prediction. So how will get to know what it belong to which class? So I can simply check the probability of it. So here see, I'm passing the dog image, so the highest probability of the golden retriever, okay, Labrador retriever, okay, and then golden retriever. So all the dog name is coming, right? Now let's say if you want to check with the other image, so you can look into this tomato image also, how it looks like. So guys, this tomato image looks like this. Let's try to predict about the tomato. So instead of giving the dog image, now I'm giving a tomato. Let's see whether my model can identify the tomato or not. Now again, this weights I'm using from the ImageNet dataset. So this model was trained on the ImageNet dataset, so I'm using that particular weight only. So I change the image path. Now here I'm providing my image again. Now here I'm doing some pre-processing of the image. Then I'm predicting it, and here is my prediction. Now you see the label. So it is saying it is a strawberry, picture, orange, hair. Okay, so all the thing related to the tomato. I think tomato will not be there inside the particular data. That's why it is not coming. But whatever thing is going to be related to the tomato, it is giving me all those things. I hope this thing is also clear. Now coming to the Bert model. Okay, so using the Bert model also we can perform this pre-trained. Sorry, we can also use this pre-trained Bert model, and we can directly do the prediction of our data. So here I'm going to load this Bert model using the Hugging Face only. So here is my tokenizer and my model. So why we use this tokenizer? What is this model? This Bert for mask language. Okay, what all other classes we have inside the transformer and all. Those things we'll discuss inside the Hugging Face classes. Okay. So here I'm just loading a model and a tokenizer. Now this is my like sentence. The capital city of the France is, and here I give the mask word. Means I need to predict this particular next one. So this is my text. Now first I'm going to tokenize it, and then I am going to create a logits. Okay, means this is my forward pass for the calculation. Then here is my this mask ID, means the tokenization which we have done. Now from there we have created the ID. Now I'm passing it to the softmax, and here is my top K, right? So softmax over vocabulary plus take top K prediction for the position. Okay. Now here I return the complete description. Now what I'm doing, I'm just going to make a prediction. See, here it is giving me a word. What could be the next word? Okay. So just read over here the sentence. The capital of the France is Paris. So it is giving me highest probability for the Paris, and the other word also it is generating, but this is the correct one. Okay. Now, likewise, you can utilize this pre-trained word model for predicting the next one. Okay, using this mask language model. Now, here I kept the example for what? For the other model, like this text-based uncase SST2. So I can execute it and I can check out what it's going to be predict. Okay. So I hope you understood the meaning of this. You understood the meaning of the pre-trained model and the tokenizer and all, guys. We'll try to discuss in the upcoming sessions. Okay, each and everything we'll try to discuss over there in the Hugging Face session. But don't worry, I try to cap each and everything inside the series, so you won't be get any issue with respect to the fine-tuning and all. So yeah, it is fine. Now let's try to conclude this session. In the next class, I'll discuss about the transfer learning concept, and we'll discuss a couple of more concepts with respect to fine tuning. So thank you. Bye bye, guys. for watching this video. Stay tuned for the channel, and if you haven't subscribed, please subscribe the channel, guys, so that you will get this amazing content whenever I'm uploading anything on my YouTube. Thank you. Bye bye. Take care.